Okay, next we go to the next one. Part C. Figure 7.3 shows a prism producing a spectrum of colors from a narrow beam of white light. Narrow beam of white light is prism, and then disperse. Disperse means like the color is separated from the white light to seven color, which is called Roy G. Biv. Roy G and then BIV. R for red, O for orange. Okay, let's see, this one is orange. Y is yellow. G is green. B is blue. I is indigo. V is violet. The prism refracts the white light. It's refracted. State the name of the effect that produces the spectrum. Do you see do you know the name of the effect that produces the spectrum? We call it as this. This is called dispersion. So dispersion is the producing of a spectrum. So you have to difference dispersion, which is um, produce production of spectrum. The spectrum is Roy G. Biv. There's also refraction. Refraction is the band of light. So this is the light is bent, right? It's straight, and then after that is bent, going to that, going to that. So it's a band of light. And there is also reflection. Reflection. The reflection is the reflect of light, which is angle of incident is equal to angle of reflection. And the last one is diffraction. Diffraction is the changing of direction. The change of direction of light. Any questions so far, Chanel, from this? Oh, sorry. The diffraction is the spread out of light. Sorry, my mistake. The diffraction is the spread out. The spread out light. Later we will learn about the diffraction, yeah? So, in the spectrum shown in figure 7.3, there are 7 colors. List the 7 colors in order they appear between X and Z. Yeah, can you mention again the color started from X to Z? Z is the most deviated, which is called violet. X is the least deviated, noted as red. Of course, there is another color between them until 7, right? So we can write here X is red. What is after red? Do you remember?
Orange.
Yes, orange. What else? Yellow. Okay.
Violet.
Green, blue, indigo, and violet. Yep. Number 3. Figure 7.1 shows a ray of diagram when an object positioned on the principal axis of a thin converging lens. I will larger the picture here. F1 and F2 are the focal point of the lens, and C is the center of the converging lens. F1 and F2 is the focal points, and C is the center of the lens. Object distance is 25, meaning that from this to this is 25. And also each small square grid represents 1 centimeter. So that means that every single grid of this is 1 centimeter. So from here to here is 10 grid, which is 10 centimeter. And from here to here is also 10 grids, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus 10 is 20. 10 plus 5, 20 plus 5 is 25. That's why it's 25. Object distance. Okay, now we see this one is, of course, this one is the image, right? Because this is the meeting, the midpoint of the refracted rays. Look, this is the incident ray and then refracted through the focal point. This is also incident ray that comes from the object undeviated to the focal, to the center of the lens, and then meeting it here. So of course this is the image, which is upside down, or we call it inverted. So what's the question? See the question. Determine the focal length of the converging lens. What's the focal length? Yeah, the number, the centimeter. How many centimeter is the focal length? Can you answer? Maybe you can calculate or count it. How many centimeter from this to this? From the center to the F1, or from the center to the F2 is the same. Can you answer this question?
Mm. Convex.
Yeah.
Is it 10?
Why 10? 10 is from this to this.
Uh,
Now it's from the C to F1. From the C to F1. I think it's not 10. From the C center to F1. Yeah, how many grid is that?
mm, um,
Yeah, I will larger again, yeah. From the center to the F1. So 1, we count together, yeah. 1, 2, 3, 4, 5, 6, 7. So there are 7, right? 1, 2, 3, 4, 5, 6, 7. So there are 7 grid, which means that one grid is 1 centimeter. So because there are 7 grid, meaning that 7 centimeter. Any question, Channel, from this?
no.
Okay. The next one. On figure 7.1, draws an arrow to show the position of the image formed by the converging lens. So this one is the converging lens, like a thick, yeah. But the diverging lens is like this. Diverging is like this. This one is diverging. Converging is like this. This is converging lens. This is diverging lens. Diverging lens is to spread out of the light. It away the light, but converging lens will focus the light like a magnifying glass. Okay, so the question is arrow. Yeah, this is the arrow, yeah. By the converging lens, the position of the image is at here. Once again, at here, yeah. This one. So an arrow is this one. The arrow is going down because this one is the image. This one is the image. So the image is the midpoint between two rays. Now, state three characteristics of the image formed by the converging lens. Yeah, can you mention the characteristic of this image? First, what is the characteristic? 2 and 3. Is it smaller? Smaller than the object or bigger?
No.
Yeah, it's smaller. Very good. Smaller. And this is the image. The image is smaller. What else? Besides smaller, what else? Is the image upright or inverted? I have a simulation like this channel. So this is the object, yeah? The pencil, and this is the convex converging lens. So if I put the pencil at the focus, this is the focus point, and this is also the focus point. If I put this pencil at focus point, so there is no image because all the light is parallel. If I put the object between the focus and the lens, so this is called virtual. So the screen cannot capture this image. So the characteristic of the image is virtual, larger, and upright. Because this is upright, right? The same, but larger from the object. But if I put this smaller than f, smaller than the focus, I mean further from the focus, so smaller, right? The object is smaller, real, because it can be seen by our eye, and also inverted. So inverted, real, and smaller. But if we put it in 2 times focus, so this is focus and then 2 times focus. So this distance is same with this 2f. It means that the object is the image is the same size, the same height, but inverted and real, like that. Do you understand what I mean, Shannon?
Yes.
Okay. If we change this, becomes the converging, diverging lens. Diverging lens becomes like this, but it's rare in the exam. Usually, the exam is the converging lens for the CIE exam. Okay. So number two is just now is smaller, smaller, and then number two is inverted, right? Inverted. And number three is smaller, smaller already, inverted and real. The object, the image is real because we can see the object, the image by the screen. There are the difference between real real is image can be captured by screen, but virtual image cannot be captured by screen. So by the screen. So the example of the virtual is like mirror. So when we are in the face of mirror, on the face of mirror, so that's the image is the virtual. Okay, this already done. 1, 2, 3, and then we back to the question number 4. In figure 8.1, each diagram illustrates a wave property. Draw a line from each diagram to correct wave property. Yeah, what do you think? This one. Is it reflection, diffraction, dispersion, or refraction? Picture number 1. Look at the wave spread, right? Spread out. And for this, the wave is bent. Now, match it. Does it belong to the reflection, diffraction, dispersion, or refraction? For picture number 1. And what is for picture number 2? Can you answer? Yeah. Remember that the spread out of light, the spread out of wave is called the diffraction, and the band of light or the band of wave we call it refraction, right? This belong to the refraction. Because this is spread, right? And if we continue, it will be like this. Continue, it will be like this. It's spread out, going to that, going to that, going to that, going to that, going to that. So it's spread out. And the spread out of wave, we call it diffraction. So this is diffraction, and it's bend, right? The first is straight, and then bend to this direction and bend to that direction. So we call it refraction. This one. Any questions so far, Seno? Now we part B. An object An object O is placed in the front of converging lens. So this one is the object, this one is the converging lens. Figure 8.2 shows the rays of light from the object passing through the lens. So this is the first ray, this is the second ray. Yeah, we will soon know that this is the midpoint, right? This is the midpoint. Of course, the image will be like this, going down. So we call it the image, right? And then what's the question? State the name of the line XY in figure 8.2. What is the name of the line XY? Which one on XY? This X, this Y. So what's the name of the XY? What call it? We call it print principal axis. So the principal axis is the line, the line where the object is there, the image is there, and also the lens is there. So this is the horizontal line, and the horizontal line is called the principal axis, which is XY. State the name of the point label F in figure 8.2. What is the F? What do you think? What is the F? The name of the point F. Yeah, what do you say? F is called for focus, right? Or we can write it principal focus. Principal focus. Um, repeat this one is principal. Okay, next one. On figure 8.2, draw an arrow to represent the image of O. Already, yeah. This is O, and the image of O is this. This is the arrow. The arrow is going down because they are inverted, bigger, and also real. Yeah. So the image is inverted and also real and yeah, bigger. Or it's bigger, or is bigger double G? Write this right. Okay.
Yeah.
Okay, next one. Draw an arrow to represent is already done. Using a ruler, measure the focal length of the converging lens. What is the focal length? But using ruler, how we use the ruler here? Yeah, maybe this question when we print this, yeah, we can answer when we print this, and we use the ruler and measure the distance from this point, the center to this, is to the center to this. This is the question means that the distance using the ruler is how maybe 1 centimeter or 2 centimeter or 1.9, yeah. So this only can be answer if we print this, yeah, but now we cannot answer because this is online. Describe characteristic of the image in figure 8.2. Yeah, tick 3 boxes. Do you still remember the characteristic of the image? Diminish means smaller, yeah, smaller. Enlarge, yeah, it's a good word than bigger, so enlarge. Okay, so can you mention again the three characteristic from this image? This is the image. This is the image. And yep, is it enlarge? You know, does it enlarge? Yes, right?
Yes.
Yeah. Is it diminished? No. Diminished means smaller. No, yeah. Same size? No, of course, right? Inverted. Is it inverted? Inverted? Inverted means that, yeah, when it's upright, it goes up, right? But this one is goes down. So, not the same. The direction is not the same. So we call it inverted. Thick inverted, like this. Upright? No, this is the contrast by inverted. Virtual? No, because we can see the image by our eye, or also can be captured by the screen, and of course it's real. Okay, Shana, any questions so far?
Yeah.
Okay. Next number 5. Figure 7.1 represents two rays of light striking a thin converging lens. The rays are both parallel to the principal axis. F2 and 1 are the focal points of the lens. On figure 7.1, continue the path of each ray beyond the lens as far as the screen. Yeah, we have to continue the line, the path.
Wait, sir. It's time.
Oh, okay.
Yeah.
Yeah, okay, thank you. Shana, goodbye, good night.
Bye.
Yeah,
Bye. Yeah.
bye.